This assessment asks us which cyclic hemiacetal would have the most favorable KEQ. Recall that KEQ is going to be equal to the concentration of the products over the concentration of reactants. Given this, if we look, we could go through and identify bonds formed and bonds broken, and we would note that it's the same for all of these. So in terms of bonds formed and bonds broken, these are identical. What's the difference? Well, the difference is in that in A, we're making a 3-membered ring, in B, 4, C, 5, D, we make a 6-membered ring, and E, we make a 7-membered ring. Given that the bonds formed and bonds broken in each case are the same, what we're really looking at here is the stability of the ring sizes. Given that the 6-membered ring is the most stable of the ring, we would expect the 6-membered ring, the reaction that forms the 6-membered ring, to have the highest KEQ. The question doesn't ask which would come in second, but probably that would be C, because it's a 5-membered ring. E would be close, being a 7-membered ring. So the 5 versus 7 would be a close competition. But the 6-membered ring would have the greatest KEQ.